Welcome to Rogni College of Engineering and Technology. Today we are going to see about fixed transmission equation. I am Reggie, Associate Professor, Department of ECE. On completion of this topic, fixed transmission equation, students will be able to derive the transmitter power and received power and to define the signal to noise ratio. Fixed transmission equation. Fixed transmission equation is used to calculate the power received from one antenna with gain G1 when transmitted from other antenna separated by a distance r and operating at frequency f or wavelength lambda. Derivation of fixed transmission formula. To begin the derivation of fixed transmission equation, consider two antenna in free space. No obstruction nearby, separated by a distance r. Fixed transmission equation. It will have a transmitter and receiver separated by a distance r. Assume derivation of fixed transmission formula. Assumption. Assume that the transmitting antenna send out a power PT. We assume that transmit antenna is omnidirectional, lossless, and the receiving antenna is in forward. That is, transmitter is in the far field from the receiving antenna. Derivation of fixed transmission. Step 1. The power density of the plane wave incident on the receive antenna, which is at a distance r from the transmitting antenna, is calculated by the formula P is equal to Pt by 4 pi r square. Derivation of fixed transmission formula. We assume that transmit antenna has the gain Gt and the power density become P is equal to Pt by 4 pi r square into Gt. We assume that the receiving antenna has an effective aperture AE, then the power received by the received antenna Pt is equal to PR is equal to Pt by 4 pi r square Gt into At. So where Gt is the gain of the antenna. If the effective aperture AE is defined as, so effective aperture AE is equal to lambda square by 4 pi GR, where GR is the receiver antenna gain. So normally if you consider the value of beta is equal to 2 pi by lambda. So we have to consider the phase constant also. So the last step, when you substituted this value, the final formula for the power received at the antenna can be denoted by the fixed transmission equation. PR is equal to Pt Gt Gr lambda square by 4 pi r square. Since we considered the omnidirectional antenna, so here you will get the value in terms of 4 pi r square. Or you can substitute the value where C is equal to, so the wave lambda is equal to C by F. If you substitute the wavelength, lambda is equal to C by S, power received PR is equal to Pt Gt Gr C square by 4 pi Rf the whole square. Thank you.